In this tutorial, we are going to automate our Azure infrastructure. So let's discuss what we have in our project in Azure. So in our project, we have a environment in which we have a resource group with a web application, and then we have a virtual network here, and in that virtual network we have a subnet, various subnet. One of the subnet is the data subnet, which contains the backend server, which is a Windows machine, for example, so that we get an idea how to provision the virtual machine in terms of IaaS as a service, infrastructure as a service component, and this is our platform as a service. And then we have some other platform as a service which are publicly available offering from Azure, such as a storage account for storing any kind of a storage in Azure. Then we have the key vault to manage the secrets in Azure, which is related to our applications. Then we also have some of the logging capabilities, such as in log analytics and the application insight, where we are going to manage our configure our logs for the application. So this is just a simple setup which we are going to configure with the help of infrastructure as a service. I haven't make a very complicated application project to configure the infrastructure, because if some of our audience is very beginner level, so we don't want to discuss something which is really complicated, so that we don't want them to be out of their comfort zone. So just to begin with it, we are going to go ahead with really simple infrastructure as a service, and this is the project which we are going to automate, and it's trying to add one. So this is what it is. Now if I run the Terraform apply command by passing the plan which we have generated, we should be able to see a new resource group created. Let's see, a resource group is created, and this is the ID of the resource group. Let's verify the resource group. We have a resource group called rgdemo1, and now if we would like to modify, let's modify the resources. For example, we'll say tags, and we'll see environment called, and we'll say dev. Okay, and we'll run apply, and you can see that in this time in the plan it's trying to modify the resource group, and with the modification it's trying to add a tag property. As I described earlier, the way Terraform works, Terraform checks the current code configurations and the actual target, the desired state of the code configuration and the desired state of the actual infrastructure, and then it maps the plan, and then the plan describes what are the changes it's going to reflect when you run the apply. So we have applied the tags to our resource group. Let's verify. So currently, let's see if we have any tags. You can see that we have a tag called environment and values dev, which is come from our source code. So this was a very first resource which we have created with the help of our own. So if I go back to our project, we have a resource group created from our Terraform infrastructure as code. Next, we need to create the web app, or virtual machine, virtual network, and these components. Okay, so let's create some of these components. So we are going to create these pass component first, and then, because these are not dependent on each other, for example, this virtual machine is dependent on the virtual network. So I'll start with, I prefer to start with the least dependent components. So these are my least dependent components. So let's create these first. So I'll create a storage account, key vault, and log analytics. So I'll search for storage account, and this is how you create this storage account. So I'll copy this block here just below the resource group. So we'll see, we'll quickly verify our different variables. So at the moment we have a location variable, resource group variable. Let's see if I'll just make it here at the top. We'll call this as an environment variables. Okay, and we are going to call the storage account name. So let's see what all variables we need to create the storage account. So we need the storage account name, the resource group name, storage location, access tier, and account type. So let's see if we use the same thing. So I'll just ignore the description for now. In the best practice you should provide the description, but just to save the time I'll just remove the description, and we will use the tags as well. For example, we would have a variable called tags, and the type will go and create a map. This time we don't specify the tags type here. Just to give an idea, you can declare a variable without specifying description or a type. So basically this particular variable will accept any type, and here as well we'll define our tags here in the variable section. You can see when you mouse over this it says required, and when you mouse over here it says type of map, and then it is optional. So I will, if you want, you can get this information like this. Let's call the var dot this, and we'll call the var dot storage account name. So what was the variable name? Storage account name. So this is how you can create the storage account name as well. So we'll call storage. So let's define the values of the replication type and access tier as well. So whatever values we have copied, we will copy the same thing. Oh shit, I have forgot to update the storage account name, so I'll call it as an now. Let's see, we are referring resource group here, and resource group instance name, instead of example we need to refer it like this. So let's see if it's work. Now you can see that it is trying to create a storage account in the same resource group. So I'll use the apply command, and meanwhile it's applying, let's search for our next resource, which is key vault. So here is how you can refer the documentation of your of the Terraform to create any resources. So let's create a key vault from here. I'll just put the comment storage account. So whatever is the name of the resource group prefix, we are going to use add a prefix, and I'm adding 3 nines so that the key vault name is, I'm making sure the key vault name is available. I'll use the resource group location name data configurations. So you need to use provide the configuration, current configuration, and to get the current configuration we basically use this block. So whichever service principal I am using right now to run this Terraform, basically it uses the same client configuration, and then we are using to define the access policy, default access policy. Basically to get the default access policy, for example, you get you have, these are the required property for key vault: name, locations, resource group name, SKU, tenant ID, and then access policies. If you wish to define access policy, you can define it like this. Now if this is a very first resource type, wherein you have seen up till now, whenever we create a resource group, you create a resource, you define the resource name and then instance name, and then you define the simple key value pairs or property as in key value pair. right? Which is either a string or boolean type. So you can see that till now we have used the string property, but now you have the boolean properties as well, which is this example. You have some number properties as well, which shows that Terraform accepts the numerical values as well. So this is how you can use the various data type. Now within the resource block, it might possible that you have the option to declare inner resource. For example, if you are aware about a class, let's say, so within the class you can have the primitive type of property, or you can also have a property which is type of class itself. So similar concept applies here. You have a Terraform resource block which has got some properties, primitive type of attributes or properties, which is simply key value pair. And then within the resource block you have got another inner level of resource block which has got some more properties, and then it has got it might possible it might follow the same pattern down the below. You can have another resource block. Okay, so this is how a resource block can have another resource block. So as it is, this is the optional right now, but let's say we would like to create this. So let's see if our storage account deployment was completed. Yes, it is. You can see that the storage account is added. I can go ahead and verify the storage account. So let me go ahead and check if the storage account is available. Yes, this is my storage account which is available. Now let's see if we run the plan for key vault. Meanwhile it is running the plan for key vault. Let's verify which is the next resource we need to create. So we need to create now log analytics and application insight. So I'll search for application insight. This is my application insight resource, which is really simple. So plan is completed. I'll run the apply. Meanwhile apply is running, it might take a minute or two. So this time, instead of creating the application insight here in the main.tf file, we'll utilize our modules. I'll go to the module, go to app insight, main.tf, and I'll use this particular module as is. So let's say I'll use the same thing, same format. So you need to have now two variables to be declared in the variable.tf file. We already have a variable called, so I'll use location variable. Now we have our application insight module ready, which is ready to create the application insight. You can pass it like this, or we have a parameter called location. So either of them is fine. Let's see, we are going to use this as well instead of resource. So let's check our deployment. Key vault is created, and now let's verify our implementation. I'll close everything else. Key vault now. We have got the storage account. We have got application insight module. So let's call our application insight modules. I'll run the plan as is. Meanwhile plan is running, let's verify if our key vault is created. I'll go to my resource group, and you can see that we have our storage account and key vault created. So this is really you can see that it's how easy it is to manage anything here with the Terraform. You can go to the documentation, add any required documentation, find the information, what all things you can use it. For example, let's say for application insight, if your requirement says you need to specify the retention period for application insight, you can specify to the value. So these are the possible value for the retention in days property or attribute. If you do not specify, this is the value. 90 days is the value, default value, which it is going to use by default. So the plan says that it's going to use the application insight, create the application insight module. I will, yeah, so let's say in the application insight I haven't used the proper naming convention, so which I don't like it, so I'll update it. Run the plan again while it is running the plan, which we know that it's going to work fine. Let's see what is the next resource. Let's create log analytics. So we'll go in log analytics. So this is the log analytics workspace we need to create. Copy as is, run the plan for the application insight. In the application insight as well, I'll put the log analytics blocks. Now let's see how do you use the conditional operation. For example, let's say if we say environments, let's check our next resource. So we have created a storage account, key vault, application insight. Now let's create a virtual network. I'll add a main.tf file and I'll copy the same resource variable file, for example. Now this is our virtual network. Obviously you don't want to hard code these parameters, so I'll add these parameters as well. For example, address space, so I'll create a parameter or attribute as address space. I'll also create a parameters called DNS server. I don't want this DNS server, for example. This is because that is just an optional. This subnet will call the data subnet because this is what we need. That's it really. And we'll define our variables called address space. I'll just okay, that's done. Now we are going to call the network block here in the next network. In the network we have the requirement for address space, so let's pass the address space value as is. That's what we need. Let's see if we are able to create a network. I'll run the plan again. So I've run the apply command so that it creates the log analytics workspace. So I'm just describing in a sequential manner how do you create the different resources, but it's not necessary to run or create a resource in a particular sequence or in a sequential manner, one by one after one. You can create write infrastructure in one way and create infrastructure in a single slot and just single run, single go. The name of the resource group in the variable we have defined is demo dash, and when we are creating actual resource group we are using it as an rg dash and then collecting name. So what I'm going to do here is I'll create one local. So if you want to do similar to this, what you can do is you can define a locals like this and then you can do it like that. So you can say resource rg name, for example. So this is going to be your resource group name, and then anywhere where you are using the resource group name you can use this local. So for example local dot gname. So you can see that it's this time it's trying to create multiple resources at the same time. It's trying to create a virtual network, key vault, storage account, because in the last run those resources was deleted, so now it's trying to recreate those resources again. Let's see. Yeah, so we have got all our resources which is required for our project. Now last resource which we need to build is the virtual machine. So we are going to use virtual machine. Okay, now let's verify our resources are ready to provision. We have created the virtual machines block as well, virtual machine module as well. Verify something. Now if you have seen that we have a network module wherein we are providing the address space, but in the network module, if I go, we have hard coded the subnet value, so which is not something we want, because it might possible in future in your project, it might possible you require to basically create a more subnet, right? So your code should be dynamic enough to accept any such request. So what we are going to do now is we are going to provide the subnet as an input parameter. So let's say we will use a variable called subnets, and here in this we are going to provide the description. Let's say subnet configuration, and then we'll say default. So you can say default like array of subnet, and then array you can provide the value name as in, so let's say subnet 1. So this is how we are defining the parameters. And now from the subnet block, what we will do is we will use the concept of dynamic. So in Terraform you have the called the dynamic provisioning the resource or the attribute through the dynamic configuration. So to do that, you use the keyword dynamic resource which you are trying to provision with the dynamic keyword, and here you use the for each loop. You provide the value. So here we are going to use basically it accepts the list type of parameters or the map type of parameter. So we already have a list called subnet, so this is what we are going to do. So in the content block, it will ask for providing the content value. I'll remove this as well. So when you provide the content, then you specify the name, and you specify like each here subnet dot value dot name, and then so basically whatever names you are giving this one, so you use the same thing here. Like if I'm using subnet, then I need to use subnet, and then value. So value of the for each object, and then in the value I will have this particular entire object. So I'm using one of the attribute at a time, name and address, things like that. And let's see if what how it works. So I'll run the plan again just to see if it is going to work fine. As you can see, it says that it has not found any differences so far. So what we can do now is we can basically, I can cut this, I don't remove this value, okay, and then from wherever I'm calling this module, let's say I'm calling from here, so I can provide the address space value or the subnet, something like that, and then var dot subnets. So this is where my subnets are going to define. So I'll say subnets. Obviously I need to create this variable in my root module or root directory. So I'm going to create a module subnet variables in the root directory. I'll just use pnet subnets, and this is where it is coming now. So even if I'm going to So step number 1, define the variable here. Step number 2, specify the value of the variable. Step number 3, pass the value to the module, because in the module we have a parameter now called subnet. So let's verify again Terraform plan. We should not see any differences so far, because in effect we are not making any changes so far. No changes. Now considering, let's say we have the requirement to create another subnet, for example. So let's create another subnet called service subnet, service, and let's call it this as in 3. Okay. Now you see that I have just modified my parameter values. I have not modified any code block. So let's see if it is going to work fine. So I'm expecting a modification in my network subnet. So it should say, Terraform plan should say it's going to create a new subnet. As expected, it's changing one value. So as you can see that basically it's going to change a subnet value. So this is how my subnet has been created. A service subnet is created now, and we have got one change in the list. So similarly, if you get any number of subnets to be created, those subnets will be added without modifying to the code. Let's call the web subnet, for example. So this is how the dynamic keyboard is very helpful, and you can conditionally basically create various objects. And we have got our web subnet dynamic block. Now let's see if we have a requirement to create a multiple object. Let's say, for example, if we require to create multiple storage account, for example. So what are we going to do with that? So in such cases, what we can do is you can use the for or for each loop, or you can use the count. So option number, you have 3 options basically. Option number 1, use count. Option number 2, use for loop. Option number 3, use for each loop. Each of them basically requires different treatment. For example, count works on the specific number operation. For example, it will work if value of count is greater than 0. If it is going to be greater than 0, then the operation will work fine. For example, let's say count, if we specify the count onto the storage account, let's say if I say count equal to 0, it means this block will not be executed. So if I'm going to run the plan now, what exactly it will do, it will destroy the storage account, because count says do not run anything, and it as our state function already has the state of the storage account, so it will try to destroy the storage account, in my opinion. So similar to that, let's say if we need to have a requirement to run 2 storage account, for example, so I could run it like 2 times, something like that, and then I can loop it through. I can again run the format function, and then I can use name of the format is $. I can use double quotes s, and then this is what I do, and then use count dot index. So this will give you the index. The index is 0 based index, as our previous plan was we have mentioned 0. In that case, this was trying to destroy. So now if I run the plan again, this will basically recreate the storage account. It will destroy the previous storage account because it was created with the storage account name, but now we are appending the storage account name with the index as well. So it will delete the existing storage account and recreate 2 new storage account. as I said, delete the existing one, which is one destroy, and create two new one. Okay, and now if you look at the storage account name, you can see that it has appended the value as 1 to the second one, and it might have appended the value 0 with the first one, which is here. Okay, now you can use the index property with the list parameter as well. So for example, let's say you can use you can, in the variable parameters, you can parameter itself, you can pass the storage account names. For example, let's say we'll call it storage account name, and we'll pass the name as in list, for example. So we'll pass the list, and we'll say 01. So 01, 02, and we'll call this 01. Okay, so these are the two storage accounts. So we are going to use the index name. So now if I go back to our storage accounts, instead of passing the values like that, so what I'm going to use is I'm going to use my index parameter, because I know this particular parameter is a list type. So I'll be passing iterate, give me the from this list, give me the first 0th index, which is the first storage account name, give me the second index, which is the index value 1. It will give the second storage account, and then I can run it like this as well. So instead of hard coding the value, what I can do is I can use the len function, something like that. So whatever is the value length value of this particular parameter, it will run those number of time. Okay, so if, for example, if I keep this as an empty, so it will not run this particular string. So let's see if I run the plan again. Okay, this was about count. Now we can run the for loop as well. So we can use the for each loop, for example, and then we can run the for each loop here on these parameters. Then we can use each dot value. So this is one of the way to use the for loop. So now we are using the same parameter, which is this type parameter, but this time we are using with, instead of using the count, we are using with for each loop. So the difference you find here, it uses the index, whereas in the for each loop it uses the key value pair. So and 2 here is not index, 2 here is, we have told our variable, our loop, that this is my input object on which this is my key. So key is going to be index, and that's the reason you will see 0 and 1, 0, 1, 2 value in the key. Now, but if you would like to give any key, so I can do it like that. So let's say this is my value, and I can say this is my storage account property, and I can again say this is my storage account property, the number 1, and then similarly I can create another one, which is 2 and 3, and here at this time we'll say this is going to be GRS type, and these two are going to be RAGRS. Okay, and so now we have construct our key value pair, because this is our map property. So instead, so within the list, this is the list of map type, and within the map we have this key and value. So map, we know that map is just key value pair. So within the map we have a key, we have a value, so this entire is the value, and within the value we have two attributes. One is the account tier property and replication property. Let's see how do we use that. So we know that we have the key, and the key is the name of the property, name of the storage account, because we know that this is our key. So this is our story account, and now the value which we are going to use. So the value is going to be the entire this object, right? So what I'm going to use is each dot value, and then the entire object, and then the property of this. So this is how I can use the for each loop. So let's see, let's run the plan again if it is going to work fine. This is what our plan looks like, and I'll see if we have a plan with a GRS, which is this one is the GRS. And let's see if the other story account has the value LRS, which is coming from the parameter. And this is how you construct the for this is how you use the for loop and for each loop and the count loop. So we have seen the dynamics, we have seen for each loop, we have seen the for loop, we have seen the count loop, we have seen how do you use the conditional parameters, conditional values. Now let's look the one of the more type in the conditional values. For example, let's say for example if it is a tier, for example let's say we will call it as an environment parameter. So let's create a variable called environment. We'll create a variable name called environment name, and then if we are going to call it, for example let's say dev environment, for example, and value as in dev. So we would like to see if the environment is equals to var dot environments equals to, let's say, dev, or prod, then use this as an premium, or else use whatever it is been passed from the parameters. So we want to make sure that if the environment is production, then this story account type has to be premium type, otherwise use whatever it is been passed, so that we are just avoiding the possibility if somebody is even trying to create a resource type Go tier which is not supported in production. So from Terraform code we are making sure that we are only allowing certain specific types. So if I run the plan now, basically it is not going to happen anything, because our environment right now is not production. So if I change this variable values to prod, then I should see the differences, right? So this is one of the conditional way of using the parameters in the conditions. So you can use it like this. Now let's look at some of the lookup values, the lookup function in our parameter. Let's understand the lookup functions. So we are going to use lookup function. So when usually I use the lookup function is when you have key value pairs or map values given to your input logic, or in your logic, if you have the map value and some of the map properties or map object, you are expecting certain values. If the values is not been passed, then you would like to take a decision what could be the default value for that attribute. In that case I refer to use the lookup. For example, in our case we have this story account parameter, right? So this story account, so So this storage account object is trying to create these three storage account. For example, let's say if I do not pass either of these properties. So for example, here if I run the plan, so it will fail because my code is looking for this replication type property, and the second storage account, which is this one, is not sending the replication property. And obviously if in that case, if the plan is going to run, it will throw an error because it has not found the replication. As you can see, I've got the error here. So in such cases where I would like to make a decision if the value is not been passed, what could be the default value. So what we can do is we can use the lookup function. So we can use it like lookup. Let's say lookup accepts a map. So here the each dot value is going to be mapped because we know that each dot value. So each dot value is, let's say this is my key, this is the entire value, this is key, this is key, value, key, and value. So this is each dot value, this is my value, and within the value I have this property. Okay, so I'm checking if each dot value has this particular attribute. If it has the attribute, it will read the value. If not, then I'm setting the default value. Okay, so I'm using the lookup function. Lookup function will check here in this each dot value and check for what? Check for this particular property. If it has find the property, it will use the value of this property. If it does not find the property, then it will use this particular default value. This is how you use the lookup function. Let's see if now if we get the error. As we can see that this time it has run successfully and without having any problem, even though from the parameters I'm not passing any which is required property, which is type of replication property for my storage account. So still it is happy and ready to create my resources. Okay, now let's do one thing. We are going to copy this entire section and we'll cut it here, and I'll go to the variable file. I'll define it here in the location, here in the dev variable, so that we are passing the parameter. So now what we are going to do is we are going to terraform plan, then use dash where dash file. So it will use dot dev dot tf okay, and then out equals to tf plan dot out. So now we are ready to create our environment, and we have the same configuration written here, but we are passing the different parameters from the parameter file. So similarly we could have the same setup, but we could have a setup created in the basically. So I'm just recreating the environment. So now if we have another environment called tf